Hello, everyone. My name is Hwangbo, and my Tech Talk topic is machine learning. So, what is machine learning? The concept of machine learning can be dated as far back as 1959. During that year, Arthur Samuel developed the first self-learning program that was eventually able to challenge amateurs in a game of checkers. He coined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Fast forward a few decades, as technology vastly improved and machine learning became more applicable to solving real-life problems, Tom M. Mitchell gave a more formal definition of machine learning in 1997 as a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. So to sum it up, I see machine learning as the ability for a program to learn from experience and is able to improve by a certain level. To further define machine learning, I will talk about some of the categories in machine learning. Three of these categories are supervised, unsupervised, and semi-supervised. In supervised learning, the machine is fed training data to solve classification or regression. Now, before I dive deeper, I want to draw a comparison between the ways that people and machines, before machine learning is applied, learn. Here's a scenario of an interaction between a parent and a little boy. The parent goes to the boy and gives an apple and tells him that it's an apple. Now, we all know that apples are not exactly the same. For example, apples have subtle or distinct differences in color, taste, and size. Now, how do people learn to generalize or classify apples? It's simple. They learn from experience. The next time, the parent gives the boy a different color apple and tells him that it is also an apple. And over time, as similar experiences become absorbed by the boy, he learns to classify a fruit as an apple, even though the apple may look completely different. In contrast, machines generally do not have this ability to classify. They are usually given a specific set of instructions and are told to perform them. That is why that there is a saying that machines do not make mistakes. With machine learning applied, however, machines can also be taught similar to people. In the case of classification, machines can be fed training data that gives the machine numerous amount of examples that define what something is and can be programmed to make generalizations based on this training data. Now, back to the overall category of supervised learning. I will list some additional properties. In supervised learning, there will be a correct answer because there is a programmer or teacher that tells the machine what the correct algorithm or answer is. The downside to supervised learning, however, is that it can be very costly because it requires people and labor to accurately label the training data that is fed to the machine. In supervised learning, machines are fed data and expected to solve clusterings. In unsupervised learning, machines are fed data and expected to solve clusterings or associations. For example, in the application of Amazon, the machines can gather the data based on the products that customers buy, and thereby learn how customers shop by grouping the similar products together. Now, there is, however, no right answer in unsupervised learning because there is no programmer or teacher that tells them what the right answer is. Instead, the machine are simply fed a lot of data. So think big data. The problem with the big data, the problem with the unsupervised learning is that in cases like big data where there's a lot of data, machines they they may come to conclusions of things that are not relevant, and it will take time to sift through the data and find the relevant find the find the relevant solutions that they need for their problems. In semi-supervised learning, this is the category that real life problems generally use the most because they combine supervised and unsupervised. For example, in credit card fraud detection, machines machines can use unsupervised learning by getting the data of by after gathering the data, they make the conclusions of how criminals may browse the internet. Usually, they found out that these criminals are very meticulous, and their browsing behavior reflects so. At the same time, they are also given supervised. They are given supervised algorithms and logic. So, for example, if if a credit card is processed in one state and then a few minutes later it's processed in a completely different state, it would raise a flag of credit card fraud. Now I would like to give some more concrete examples. So up here is is a portion of my Facebook page that shows image tagging. Here, based on the way that users tag faces of themselves or their friends or relatives, Facebook can identify similar photos through the training data supplied by the users. In Netflix, when users play movies or TV shows, the machine can learn what type of movies or TV shows that people like and make recommendations to them. In Google machine learning, for example, Google Translate is one of the machine learning technologies that they apply to. In Google Translate, the machines are fed patterns or words of okay, then I have to edit this part out. In Google machine learning, one example of Google machine learning is the way they use spam filters. Now, the advantage that Google has is that they collect a lot of data, and they have access to a lot of data. And because of that, they can put unsupervised learning to good use. And in the real world, at first when they implemented their spam filter, it did not filter out as much as it currently does. But after several years of learning, it can now filter out 99% of the emails that are spam. And finally, this is the credit card fraud detection that I talked about earlier. Now, I would like to give some demos. In here, this demo is a convolutional neural network in which machines are given a data set called the MNIST digit data set, and it's a collection of handwritten numbers, and although these numbers do not look exactly the same, after given a certain number of examples, the machines can more accurately determine what the number is. So I'm going to refresh this page. And as you can see here, there are the machine is processing and determining the numbers. Now, at first, the machine has a hard time determining what the number is, but as they are fed data, as you can see, the machine is already making vast improvements on what these numbers are, even though they are not all the same. But based on the patterns and the given examples, they they are able to determine what is the number. And I would also like to share a code that I've written that uses Microsoft Azure's Emotion API. And based on the picture or video, they are able to determine the emotion state of the person. So here I will take a snapshot, and I'm going to put on a sad face. And look, the Microsoft Emotion API was able to determine that I was feeling sad. So it wants to cheer me up, and it's asking me to play an uplifting song for me. So okay, sure. And wait a few seconds as the browser processes this. Don't stop me, 'cause I'm having a good time, having a good time. Shooting stars into the sky like a tide. And look, I'm feeling better already. So machine learning, it seems great, and there are a lot of good applications in the current world. But I would also like to draw attention to a caution from someone who I really respect, and he is Stephen Hawking. He said he did warn that the machines can cause the end of humanity. I know it's pretty severe and extreme, and a lot of people who goes against it says that we are nowhere near the technological level for that to happen. And I personally have a more optimistic feel to it. I think that it can be applied to good use, but at the same time, we should always have a reminder of when developing any technology, have that caution in the back of your head, and just make sure that that it won't be put to anything harmful, so that this doesn't happen. Instead, after developing machine learning well enough, hopefully we can experience something like this. And finally, I just want to thank you for listening, for watching my tech talk.